Hello everyone, this class is Math Core and the topic is the inverse trigonometric functions. Actually this one is belong to elective math, but I moved to core math. The way gonna be too much in elective. Okay, then we start. Inverse trigonometric functions. First of all, we have to, everyone still remember about the definition of functions. Okay. Definition of function is have to be one-to-one function, correct? 1x, 1y. So a function f have a inverse function if and only if f is a one-to-one. So that means inverse function have to be one-to-one function also. Okay. So in this case, we first of all we come back to see the graph of the sine y, right? So if we have y equal to sine x like this. Here, this is a graph of sine function, correct? So start from 0 and then up to this point is x equal to pi over 2 and so on pi and this 3 over 2 pi and then this one 2 pi. So this is a complete one cycle. If this one rotate according what? Plus y according anti-clockwise. But if you rotate on the left hand side, that's a anti-clockwise. Okay. So in like a C, if we talk about unit circle, remember unit circle like this, right? If you rotate this one, come here is a one cycle. That means from here to here. And then if you rotate according this down here, right, to this side, so gonna be this one cycle, and then so on. So that's why if they use unit circle, is like this shape, but you couldn't see each cycle how to look like. But then mathematicians just move this unit circle picture here to be moved up like wave like this and so on to right hand side and left hand side. So again, the height, the maximum point of the side is what 1, minimum is -1, correct? So then you see one we this is collected of the sine function. Okay, so then if you want to find out the inverse sine function, then must have the restriction. If we don't have restriction, then the sine, this inverse sine function won't be the function anymore. Gonna be like a relation. So we have to restrict. Okay, then the one I say this one we thought about the sine inverse sine function, you will see that you will understand later. Okay, but now we come back to this y equal to sine x first. So we have two restriction now. Restriction is from where to where? From x equal to -pi here. And the x equal to up to between, just say from here to here. From say the domain x have to in the domain of the interval, of x must be here. X less than equal to pi over 2 and -pi over 2 from this to this. Okay, so then that means perhaps to restrict from here. I draw on a graph. This one, okay. So the pink curve here is a restriction for the domain. For a sine x, which is gonna have the inverse function. Okay, so that means from here to here, right? The interval for the inverse sine function. So when we restrict the domain to the interval x between -pi from -pi over 2 to pi over 2 include, okay, because you see this one have equal sign. It's include, so from this to this. So we can conclusion the property of this y equal to sine x. So that means if x domain x between here, the first one, the property of this one gonna be, you can see the function of when y equal to sine x, y equal to sine x is increasing, correct? Is increasing. Why? You see this from the left, we always say in the function increasing or decreasing, we start from the left hand here, right? And this keep moving from the left and increasing now. For the first property of the y equal to sine x, in the restriction have to be from here to there. That's gonna happen for, just say, the inverse sine function can be exist. It can be existed. Okay, and the second one, the if on the x interval from here to here, right? We can see y equal to sine x. This one will take on its the full length of the value of, gonna have the range the sine x, or just say y, right? Between 1 and -1. That means this one the height 1 and -1. And the third one, if the domain drop in this interval, the restriction here, this one, the y equal to sine x is 1-to-1 function. Okay, so when this character, this property happen, then we can say when so on the restricted domain of this one, x drop in this one, right? Pi, negative pi over 2 to pi over 2, then the y equal to sine x can have a unique inverse function, which is called inverse sine function. Okay, in this case we can write it down that, say, y equal to arc sine x, or we can write it down as this way, arc sine of x. Okay, so then we can see this arc sine of x is between another word, this one gonna be arc sine x is gonna be this one less than equal to pi over 2, and this one negative pi over 2. Okay, so then this is the definition of the arc sine x, or the inverse sine function. So don't forget, for arc sine, for the inverse sine function, have the restriction, right? That means have to be between here. That means this one here on the bottom here. And can say the domain of y is the arc sine x. It have to be close 1 and 1 here. Okay, and the range gonna be what? Negative pi over 2 and pi over 2. Okay, so that is a definition of inverse sine function. Now we go plot the graph for the inverse sine function. How's it look like? One, we know this one, the inverse sine function. I mean, for the y equal to sine x already. So now we're gonna, if from this one, we're gonna plot graph of this one. If we're gonna set plot the graph of y equal to arc sine x, or just say you can write down this one also. Okay, so again, one more time before we forget. Arc sine of x here, this one, okay, this one is not equal to 1 over sine x, okay? This and this different meaning, okay? So this represent inverse sine function, but this one over sine x, if you want to, this one mean is what? Mean the sine x and the whole thing power -1. So it's not the same meaning, okay? So this one not equal, this one's not equal, okay? So now we come back for podcast for the sine x. I will move this one. This is a y. This one y equal from here, okay? This one arc sine x. The restriction down here. If and only if this one become sine y equal to x. Okay. And the restriction, this one's a x, okay? And this one's a y. So I'm gonna write down here. So I need more space. So y equal to, just say length, maybe, or y. Become close pi over 2 and pi over 2. So I can erase this one. I need more spaces. This one if and only if sine y equal to x. Okay. This is a definition of the arc sine inverse sine x. Inverse sine function, just say that. Okay, so now we plot graph of this one for the inverse sine function. Again, because you see when we have y equal to sine x, right? Y equal to sine x, when you invert, you replace x to y, y to x, correct? I erase this one. Sorry, that's okay. Then this one, right? When you invert sine, this is the inverse sine function, then you have to write down. Inverse trigonometric function. Okay, so when you inverse, get the inverse sine function, you have to replace x with y, y replace with x, y swap. So become x equal to sine y. So now we're gonna plot this graph, right? So when you invert this one, you see before this one x here, right? X represent pi, right, or the value of pi, and the y-axis represent with the number here. So then when for the arc sine x or inverse sine function, we're gonna swap it. So this one still y and this one x, but the x right now become number. X become number now, like a 1, 2, and so on. And this one gonna be -1, -2. Okay, and this one gonna be pi, gonna be this one pi over 2. And then down here become negative pi over 2. And then this is 0. Then we can plot graph. Okay, so then we plot graph. Right now we have plot this graph, okay, in the inverse function. So from this one, I have just say x equal to sine y. Okay, then we replace, you can start by if y equal to 0, y equal to 0, right? So you replace there. If this one, if y becomes 0, y0 is what? The first quadrant, right? Y up or over hypotenuse, so becomes 0. So then this becomes 0. Then x0, so we can this point. You can use a table if you want, right? But we can do right now, like just replace right away. So if next one, if y equal to maybe say pi over 4, 45 degrees, so become what? Sine 45 is what? Square root 2 over 2, square root 2 over 2. So approximate 2.70 something, about just 0.7. So somewhere here, right? 0.7. So x gonna be 0.7 here. When it's a pi over 4, so about half of this one. So met at this point, gonna be at right here. So gonna be about here, okay? If that's 0.7. So if we replace next, say if sine equal to pi over 2, sine pi over 2 mean 90 degrees, right? 90 degree, you can see the first quadrant. So here, approach to 90. So up over hypotenuse is a 1. So x become 1. So if y pi over 2, x become 1. It's about here, x1 here. So they measure out here. Okay. Now next one, keep doing. From right now, this is the right hand side here. Now to the negative. Okay, so if sine negative pi over 4, right? So the formula you remember. So sine negative theta gonna be minus sine theta, right? So this one gonna be minus sine pi over 4, right? So that means equal to negative what? Pi over 4 is square root 2 over 2. Okay. So then this gonna be approximate negative 0.71. So if this side is come down here, negative pi over 4, so they will make about negative 0.7 somewhere around here. Everyone can see now, this pi over 4, okay? And then negative 0.07 should be somewhere right here. They will symmetry from that. So, and this one should be a little bit curved, right? And then same thing when sine negative pi over 2. So become negative sine pi over 2. That means sine 90 is 1, so become negative 1. So sine 90 negative here. Negative pi over 2. So we'll make x equal to negative 1 right here. Approximate. Approximate right here. Okay. So now we have approximate curve now, because don't forget restriction for y have to be negative here. Include, right, negative pi over 2 and pi over 2, so right here. So this one gonna end up right here. So the curve should be somehow like this, a little bit curve. They have to be like a symmetry, okay? Okay. So you can see this. This is a graph of the inverse sine function, and this is a graph of y equal to sine x. But then one the restriction, that's this one. That's why we have to restriction here for the arc sine. So if you don't restriction for between here negative pi to pi and negative pi over 2 and pi over 2, then the graph will keep going like this, correct? Up, up, up like this, and then this one gonna be down, 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 and then final is what? It's not function anymore. Everyone get? If you go on, right, go over pi over 2, the graph gonna go up like this, right? Right, like this go up. And the bottom gonna be go down like this, curve like this. So then x have to y now. So if that's why we have to restrict restrict the value of here y, the range. Okay, and of course for the x value still here, right, 1 and -1 still here between. Okay, that's a graph of sine, inverse sine x. Everyone get the idea? Maybe my graph not really nice, but try to, the main thing, try to understand why we have to restriction for the sine, the arc, the inverse sine function have to restriction for value of y. And then just swap by value, just swap x to y, y to x. Okay, now next one, we try to take a look for some example. Okay, next one, right? So just say, for example here, if let's find this one, find the exact value. For question A, say if we have arc sine, -1/2. One thing is for the inverse function, most of the time we can find exact calculation. We can find exact value. Okay, we don't use by approximate. Like this one, question A, arc sine -1/2, or we can write it down in this way, correct? -1/2. So this one inside here is a x. So we know right away this one, that this one we can say because of sine -1/2 of sine is what? Sine x which is equal to 1/2 is how many degree? 30 degree. That means is what? Pi over 6, right? So we can have this one because this sine -pi over 6. This is equal to -1/2. Okay, and then you can see, and this one because of -pi, can say -pi over 6 is lie on what? The interval, right? For the restriction, that -pi/2 and pi/2. Okay, this one drop in here. The definition of inverse sine function from the first page, remember? That the one with restriction for the domain, that one. So this one drop in there. So this one is work. So then we can say arc sine 1/2 will equal to -pi/6 or -pi/6. Okay. So now we try maybe 2 more example. If phi, just say arc sine of √3/2. Okay. So this case you can see right away similar to question A. Arc sine √3/2. √3/2 is sine what? Sine how many theta? 60 degree, correct? 60 degrees, so equal to pi/3, right? Equal to pi/3. So then this one equal to pi/3 right away. Okay. And then this one you don't need to use calculator, correct? You can find exact value. Everyone still remember the special degree of special angles? For this one, maybe I can do this way, right? Put the, let's see, if everyone still recall, I give you this table, right? For the special angle, but sometimes you use count by finger, the one. Okay, now we have this one. I like this way. Oh, sorry. So I draw this one. I have one more line here. if you recall about this one, we have this one, right? This one, sine, cosine, tan, tangent, tan. So this one 30 degrees, 45, 60, right? So this one's a 1 over 2. This one 1 over square root 2 or root 2 over 2, correct? And this one root 3 over 2. And this one is, you do cross multiplication here. So become 1 over 2. And this one cross to this side gonna be root 3 over 2. And this one, the middle one, you just bring it down. Become 1 square root 2. Either one, okay? So this one root 3, 1 over root 3, square root 3. So take one on the top, like the next first one, and the bottom one, like to the next table, next slot. So that is the table. So you don't need calculator at all. Even you have exam, you can use this one right away. Okay. Now for try the next one. If the last example maybe, if I have find this one sine 2, arc sine 2 equal to, this one will really fast, right? You can see this is the x. You can calculate this one right away. Inside arc sine here, 2 is a x. But don't forget the x is this one equal to x equal to 2. Okay, but you remember the domain of the inverse sine function have to be between -1. Have to be not between, from -1 to 1. That include, we have cross sign here, include -1 and 1. So then 2 is an outer bar, right? Not inside here. So then this one can say what? It is no solution, or it is not possible to evaluate for the value of y. To evaluate the value of this one, I mean the arc sine too. So this one, no solution, you can say that, and no answer. Because this 2 is out of bound of the restriction of domain. Okay, so now this is a kind of example for inverse sine function. Okay, so now next, I'm gonna stop right here first. And next one, we're gonna talk about the inverse cosine function and the inverse tan function. Okay, so I think that's all for today. Bye bye. See you next class.